use these sensors to protect infrastructures, such as roads or railways, where you can stop the traffic to protect the users, and 60 seconds of advance can be very important. Also, in this case, you need, of course, to use an algorithm, and you can use the same algorithm that I showed you before, except that you have to apply the algorithm not to the stage, of course, but to the intensity of the ground vibration. So if you detect an increase of the intensity of the ground vibration that occurs within few seconds, you can set the alarm. This type of algorithm is being used and studied both in the Ilgraben torrent in Switzerland and also in the Rebaixader in Spain. In the Gadria torrent, we have installed an equipment, a new recording equipment that is capable also of measuring the frequency. And here is one of the first results that we have obtained last year in 2013. You can see with the green line the main frequency of the event, and with the blue line the graph recorded through the geophone. And what you can see here is a sudden drop of the frequency, which passed from 50 Hertz down to 10, about 10, and then keeps more or less constant. Actually, there is a trend, a growing trend, a little growing trend here, but however, the frequency can be easily detected to be much lower than before the arrival of the flow, and this drop in frequency occurs exactly about 50-60 seconds before the arrival of the debris flow at the sensor. So also this information regarding frequency is very promising as far as warning algorithm is concerned, because if we will find that this occurrence is common, every debris flow show this particular pattern for the velocity, for the frequency, this information will be possible to use also this information in preparing consistent and robust warning algorithm. Actually, also in Austria, the Bocconi University, researchers are investigating precisely the use of microphone in the band of low frequencies to detect the passage of debris flow. So this is a particularly interesting feature of debris flows that is investigated exactly during these years. In the Gadria torrent, we have designed and installed a multifunction recording unit of new conception that can be precisely employed for the detection and the warning for debris flows. This particular recording unit is capable of using a changeable amplification of the signal, so that, as I told you before, if the debris flow moves its bed from one ear to the other, you can just easily change the amplification of the signal and be able to detect the debris flow even if it moves farther from the sensor. Of course, you can also move the sensor, but the possibility to change the amplification is particularly important. Different processing methods are implemented on board, because I will not talk about this issue here, but there are different methods to process the rough data coming from the geophone, and we are studying this matter to identify which is the best way to process the data. And as I mentioned before, and I also show you a graph, the recording unit can detect the frequency of the signal, and then also the ratio STA LTA, which is the short-term average above the long-term average, which is a particularly useful information for warning algorithms. This particular recording unit has been designed, constructed and installed in collaboration with an Italian company which is collaborating in the researches in the Gadria torrent, which is the SIAP Micros company. You can see here the unit installed in the Gadria, and here below on the right there is a photograph taken from the video that I showed you at the beginning, and with the red dots it's indicated more or less the position of this recording unit. We have set in the Gadria torrent a goal to reach with the use and the construction of this recording unit, which is the goal of implementing the volume estimation on board. If we will be able to do this, of course, the recording unit will not only become a monitoring unit, but also it will also be possible to use it as a warning tool. In which case, well, I think that the video that I'm going to show you will describe this very well. We are here, you will see a debris flow taking place along a motorway, in particular the A22, close to the municipality of Fortezza. This debris flow takes place exactly above the motorway. There is a retention basin that keeps the volume deposited by the debris flow, preventing the material to reach the motorway. But of course, the question is that retention basin large enough to contain all the material? So if we could put upstream of this retention basin a recording unit like that, we could be capable of measuring and monitoring the volume directly at the passage of the debris flow. An answer to this question could be given by the administration of the motorway and decide if it is possible, if it is necessary to stop the traffic or not. Here is the video. This is a video that can be found on YouTube. is available, and you can see here the motorway, and you will see the debris flow arriving. Here it is, and there is a comment of the tourist that shot the video and that you are listening. And the tourists that are shooting the video are very scared because they see all this material arriving, and the motorway is right down after this wall, this concrete wall. But of course, they do not know that here this wall is the wall that is building, has been constructed to build the retention basin. However, the question is, how much material is the retention basin capable of containing? Who knows? Well, of course, the volume is known, but how much volume is coming down here? So the possibility to install a recording unit capable of measuring the volume could be a great help to warn and decide what to do. This is just the same location, just shot from a greater distance. You can see here the wall and here the motor car passing through. Just a few acknowledgements at the end of this talk. The study that you have listened about has been funded through the European Territorial Cooperation Alpine Space Program 2007-2013, the SEDAL project in particular, and by the Autonomous Province of Bolzano, in particular the Kineflow project. Thank you very much.